Today, we're going to unpack something pretty incredible. The century-long journey that took a nation from, well, basically nothing, to the absolute forefront of aviation. This is the story of Turkish aerospace, a wild ride from early, almost forgotten prototypes all the way to the high-tech drones that are literally reshaping warfare as we speak.
So let me ask you this. How does a country go from a single hand-built wooden aircraft to a stealthy, unmanned jet fighter in a single human lifetime? I mean, really, look at that. That's the core question we're tackling today, and trust me, by the end of this, you'll have the answer. It's a story of vision, unbelievable persistence, and one very, very big strategic bet.
All right, to understand how we got to today's crazy advanced technology, we have to rewind the clock, way back. We're starting at the very beginning, with the pioneers who looked up at the sky and believed a national aviation industry wasn't just possible, it was absolutely essential for the future.
You have to understand, these early aircraft weren't just isolated projects. They were these huge, powerful statements. When Vehicii Hercules built his KV back in 1925, that was a symbol of pure national determination. Then you had visionaries like Nuri Demirel who followed, setting up workshops that trained the first generation of Turkish aviators. By the 1940s, state-run factories were churning out everything from trainers to ambulance planes, proving that, yeah, the country could build a whole range of different aircraft. This was all about building a national ambition, one piece at a time.
And you know, this ambition came right from the very top. Ataturk's famous line, "The future's in the skies," that wasn't just some catchy phrase for a poster. It was a national directive. It basically set in stone that aviation was going to be a cornerstone of the new republic's identity and its future.
But here's the thing. The path from those early trainers to today's high-tech drones, it wasn't a straight line, not at all. The next phase was this long, methodical, and kind of slow process of learning, of mastering incredibly complex systems and patiently building an industrial foundation.
A really pivotal moment came in the 1980s when Turkey started producing the F-16 Fighting Falcon under license. Now, this wasn't just about screwing together a jet from a kit. Think of it as a decades-long masterclass in advanced aerospace. It forced the entire engineering culture to level up, mastering things like micron-level precision manufacturing, complex global supply chains, you name it. Mastering a world-class fighter gave them the industrial DNA, the expertise, to eventually design their own advanced planes, like the TAI Hercules. The Hercules isn't just a trainer, it's the physical proof of all that knowledge being passed down from one generation of tech to the next.
And this experience wasn't just about fighters either. Over the decades, Turkey built this incredibly comprehensive aerospace capability. They mastered everything from basic trainers to advanced jets, reliable transport planes, and a whole family of helicopters, utility, heavy lift, the whole shebang. Every single project added another layer of skill and knowledge, creating this deep, versatile industrial ecosystem that could take on bigger and bigger challenges.
Okay, so now let's get to the moment where everything changed. This is where all those decades of quiet, foundational work suddenly just erupted. It created a technological revolution that honestly took the entire world by surprise.
And this evolution happened so fast. It began with simple surveillance drones, early experiments that were really critical for just learning how autonomous systems work. And then came the game changer, the Bayraktar TB2. It was reliable, it was brutally effective, and most importantly, it was battle-proven. This wasn't a prototype anymore, it was a revolution on wings. From there, it just took off. We see the TAI Anka S with satellite control for incredible range, and then come the heavy hitters, the twin-engine Oxengur and Akanji, which are basically flying command centers with massive weapon payloads.
If you want to put the impact of the Bayraktar TB2 into perspective, just look at this number. More than 30 countries now operate this drone. It didn't just change the game for Turkey's military, it fundamentally changed the math of modern warfare for nations all across the globe.
And get this, the breakthrough wasn't only in surveillance, it also launched a whole new class of smart weapons. We're talking about loitering munitions, or so-called kamikaze drones like the STM Cargo and the Alpagu. You can think of them as robotic hunters. They can be sent to an area to just wait, to loiter, identify a target, and then conduct a surgical strike. It's a completely new dimension of precision firepower.
So you might think the drone revolution is the end of the story, right? Well, not even close. It was actually just the launch pad for an even more ambitious future, one that's aiming to compete at the absolute highest levels of aerospace tech. And this ambition is now following this fascinating two-track approach.
It's like they're betting on two different horses to win the same race. On one hand, you have the Taycan, the crown jewel of their national engineering, a full-blown fifth-generation stealth fighter designed to go toe-to-toe with the world's best. But on the other hand, you have the Bayraktar Kızılelma, an unmanned fighter jet. It represents a totally different philosophy, the future of autonomous air combat, taking the pilot out of the cockpit entirely.
And they are pushing the boundaries of stealth way out there. I mean, look at this thing. The Anka 3 is a flying wing design, engineered from the ground up to be almost invisible to radar. It's a true ghost in the machine, built for deep strike missions where not being seen is everything.
But being invisible is only half the battle these days. The real next frontier isn't just stealth, it's autonomy. It's about creating aircraft that can think for themselves, react to a chaotic battlefield, and make critical decisions without a human needing to control their every move.
And once you have smart, autonomous aircraft, that leads to the ultimate force multiplier, swarms. We're talking about advanced munitions like the STM Alpagat, being designed to work together, as a team, coordinating attacks on multiple targets at once. They can overwhelm even the most advanced defenses through sheer numbers and shared intelligence. Now this is the future of air power.
Which of course brings us right back to our original question. How in the world did this happen? How do you go from a fabric and wood biplane to an entire fleet of autonomous, swarming, stealthy jets in just 100 years?
Okay, so here's the answer. This was absolutely no overnight success. It was the result of, first, a century of pure ambition, starting with those early pioneers. Second, it was built on decades of patient foundational work, mastering the less glamorous stuff like trainers and transports. Then came the masterstroke, a huge, strategic bet on unmanned systems. They focused on a disruptive, cost-effective technology at the exact right moment. And finally, it was about building a competitive ecosystem at home, where different companies are constantly pushing each other to innovate and be better.
The story of Turkish aviation is really a powerful case study in long-term strategy. It's a blueprint for how this can be done. And it leaves us with one final, fascinating question to think about. When you look at the world today, who else has that kind of ambition, that patience, and the strategic vision to be the next nation to make a leap like this?